In the previous video, we derived Bayes' theorem. In this video, I'm going to show you how you can use this theorem. So let's say you've been given two boxes and you randomly pick a box and then you open it up and then randomly pick a ball within that box. Suppose you picked a blue ball. What's the probability that you picked a box? You picked box 1. So draw a map of all the things that can happen. So here you have a choice of box 1 or box 2. And suppose you picked box 1, then there's a 1 in 3 of getting a blue, 2 in 3 of getting a white. Suppose you picked box 2, there's a 2 in 5 of getting a blue, and a 3 getting a white, 3 in 5. So let A be box 1 and let B be blue. So define A and B as being box 1 and 2 and B as being blue. So the question is, given that you picked a blue ball, what's the probability that it was box 1? So A happens to be box 1. So this is box 1. So this is what you're trying to work out. You actually need Bayes' theorem to work this out. So given that you picked a blue ball, what's the probability that it was box 1? So that's you trying to find, basically you're trying to find this thing here. So let's try and do this without Bayes' theorem, and then I'm going to show you how you can use Bayes' theorem to work it out so that you can understand what's going on here. So let's try and work this out. So hang on. Let's do it without Bayes' theorem, and then I will show you how to read this thing. So we ultimately want to work this out. Probability of, given a blue ball, what's the probability that it was box 1? So this is what we're trying to work out. So this here is a map of all the things that can happen. Well, given a blue ball, you can only go down this branch here. This branch is bad because it was a white ball. Here it was a blue ball, and here it's a white ball. So this here is a bad branch. So remember, if I were to ask you, looking at this Venn diagram, what given B occurred, what's the probability of A? So you would get the whole thing. Which was 5, and then get the part within B. So this here is 2. We've seen this in the previous video. So same idea here. The whole, given blue, is the whole population is this branch plus this branch, and then you want to know that you selected box 1. So which means box 1 is you going down this branch. It will make sense later on. Bear with me, it will make sense later on. So to answer this question, for blue ball to occur, you must have gone down this route or this route here. So hang on. So the whole population is this branch. What is this branch? It's this and this. So you need to get a half times a third. And then plus, well, don't forget you've got to plus this branch here. So that would be a half times 2 over 5. And then so this here is your whole, given blue, you must have gone down this branch or this branch. That's like the whole population. Now you need to get the parts. The parts being this thing here. This is the only good outcome because you want to know the probability of getting box 1. You can't go down here, that's box 2. So you have to get this branch. So part of the part would be this branch here. So that would be a half, box 1, and then blue, times a third. So this here is your answer. Whatever it is, you can just use a bit of mathematics to compute this number here. It would be your answer. Now let's use Bayes' theorem. Let's do the same thing, but from the perspective of Bayes' theorem. So Bayes' theorem is, given B, meaning you've just selected a blue ball, and A is box 1. What's the probability that it was box 1? So we are working out the same thing, but this time we're going to use Bayes' theorem. So Bayes' theorem says the whole of B. So the whole of B is so we need to compute this thing here. Probability of B, probability of getting a blue, basically. Well, getting a blue would be this thing here and this thing here. So you can go down this branch or this branch here. So for this bit at the bottom would be probability of B, meaning probability of blue. Getting blue would be a half, would be a half times a third. And then, or you can go down this branch of getting a blue because we're working out probability of blue. So that would be plus a half and then times 2/5. Basically, that's the same as this up here. These two are exactly the same. Now let's read this. Now we need to read what this means. This P bracket B given A. So given A, so meaning given, just looking at this box, ignoring this thing here, given A has occurred, meaning you've just picked a box 1. You just picked box 1 because given A, what's the probability of B? So what that means is, given that you selected A, meaning box 1, given that you selected box 1, what's the probability of you getting a blue? So what that means is, looking at this, you've just given A, meaning you just selected box 1 up here. What's the probability of you getting a blue? It's actually a third. You can see it here, a third. Or you can look at it from here. You just selected box 1, and what's the probability of you getting a blue? So that's a third there. So it's like you standing here. You've just selected box 1, given box 1. What's the probability of blue? So it's just this, just a third. And then you times probability of A. Probability of A is probability of picking box 1. Well, box 1 is a half. You can either pick box 1 or box 2. So what's the probability of you picking box 1? That is just a half. Just a half. You see, this thing here is the same as this. This thing here is the same as this. So you can actually work this out without using Bayes' theorem. But I just wanted you to use Bayes' theorem so that you can see what's going on. This whole thing here is a third. This bit here is a half. And this probability of blue is like exactly the same as up here. Okay?